4.2, now we're doing sums of geometric sequences. So just like we did sums of arithmetic, now we're doing geometric. So this first section is just the explicit form again, because we're going to have to know it and use it. And then, oh, there's a typo. To find the sum of a geometric series, we can find each term by hand. So do it all one by one. Or we have a formula. So here's the formula. Here's what everything is. We're going to do an example where we use the formula just so you can see it. So we have a sum here because it has our Greek letter sigma, which means sum. Remember, we're starting at n equals 1, and then we would end at n equals 10. And so we could go through and we could find all 10 values and then add them up, but this formula is a lot easier if you know how to use it. So a sub 1 is the first term, and this is why I gave you the explicit formula. This formula is this. So we have a1 times r to the n minus 1. So the first term is 3. You just have to know how to read the explicit formula. R is -2. Again, it's in the formula. And then n is the final index, and that's this ending number at the top. N equals 10. So now we're going to plug everything in. So s sub n, that means the sum, is the first term, 3. And then we're going to multiply it by 1 minus r, which is -2. I'm just copying this. To the n power, which is 10, divided by 1 minus r, which is -2. So it's all set up. We're going to put it in the calculator. So 3, and then 1 minus -2 to the 10th. And then, I'm going to have to highlight this whole thing, and then divide 1 minus -2. Okay, so I just copied it exactly how I wrote it, and that sum would be -1023, which is faster than going through and calculating 10 times and then adding up your numbers. That's why we like the formula.